Okay, so as we continue to prep for the final exam here, well, problem 66 says it is thought that not as many Americans buy presents to celebrate Valentine's Day anymore. A random sample of 4,000 Americans yielded 200 or 2,200 who bought their significant other a present and celebrated Valentine's Day. Estimate the true proportion of all Americans who celebrate Valentine's Day using a 95% confidence interval, and then express the answer in the form of p hat plus or minus e. And again, that e is your margin of error, is what that e is. So again, a couple ways you can do this. We're used to using the technology aspect, the TI-84, to go through things. But the first thing I want to go through is the p hat. So as we look at the p hat aspect, p hat is the 2,200 over the 4,000. So if we go through, just reduce real quickly, the zeros can cancel, and that's 22 over 40, which is 11 over 20. And then if we divide that out, we'll find out that that's about 0.55. So that lets me know it's got to be either A or C. Now it's just a matter of, do you want to do it by hand or use the calculator to figure out what the margin of error is, for the confidence interval. A 95% confidence interval, again, it's proportions, so we would use like p hat plus or minus z star times the square root of p hat times 1 minus p hat over our sample size. So this one would be, as we look at it, 0.5500 plus or minus. The z star for our 95% confidence interval is 1.96 times the square root of, again, our 0.55 times 0.45, because that's what 1 minus 55 is, over 4,000. And so we really just need to simplify this part to figure out what goes after the plus or minus symbol. So if that's the way you like to go through and do it, and you have that formula on your sheet to work, which is not a bad idea to have as we look for trying to find minimum sample sizes for the margin of error, is to have that on that sheet. I'm going to go ahead and go back over here, and we're going to get the calculator open, and let's go ahead and do a confidence interval, a one prop z interval is what this is going to be. So go over to here, one prop z interval, which is on the next screen. There we go, option A. And as we get that screen a little smaller, I had 2,200 out of 4,000. It's already defaulted to a 95% when you turn it on, usually when it's kind of refreshed. And there's my confidence interval. So now what I need to do is, I know my confidence interval is 0.53, 458 to 0.56, 542. There's my confidence interval. So now what I need to do is just, if I want to find margin of error, is I need to subtract those two numbers and divide by 2. So real quickly on the calculator, 0.56542 minus 0.53458, and then divide that by 2, and I find that it's 0.0154. So there we go, right there. So my answer is C. All right, let's go to the next one. I'm going to go ahead and move the calculator over, give us more room here. It is thought that not as many Americans buy presents. Same situation, random 4,000, 2,000, 2,200 bought it. What sample size should be attained if a 90% confidence interval was desired to estimate a true proportion within 4%? So that's my margin of error. That's my margin of error. So in this case, what we need to have is, what we need to use, I'm going to circle it in orange here. We need to use this back half of this formula. That's why it's not a bad idea to have this formula on the sheet. Margin of error greater than or equal to the z star times the square root of the p hat times 1 minus p hat over sample size. Okay? So now we know our margin of error is 0.04, so 0.04. Greater than or equal to, we need to figure out, okay, what is the z star for a 90% confidence interval? So we're going to use an inverse norm on that one. Remember, it's inverse norm. Our area would be 1 minus 0.90 divided by 2. So that would be 0.05, because it would be 0.1 divided by 2 is 0.5. And then our mean is 0. Our standard deviation is 1. So let's go ahead and get that. Boom, boom. And then we're going to go in here. We go second vars, option 3. 0.05 is my area. Leave those two alone. Again, we're going to do a left tail there. We just get to take off the negative. So 1.645 is what we're going to use here. So 1.645 times the square root, 0.55 times 0.45 over n. All right. So we're going to leave. I'm going to try to make that a little bit smaller, but keep it on the screen because we're going to use it to do math. So now what I need to do is start solving for the n. I got to start doing inverse operations here. And I'm going to divide both sides by 1.645. So 0.04 divided by 1.645 got to be greater than or equal to the square root of those two things multiplied together. So let's find out what 0.55 times 0.45, 0.2475 over n. So now we can always divide that fraction out. I just like leaving it the way it is and doing it all at one time. So I'm going to square both sides to get rid of the square root. So we have 0.04 over 1.645 quantity squared greater than or equal to 0.2475 over n. And as we talked about earlier in the course, through inverse operations, the squared part and the n trade places. So n has got to be greater than or equal to 0.2475 over 0.04 1.645 quantity squared. So that's what I'm going to type in the calculator. So alpha fraction, and then I'm going to type in 0.2475 on top. On bottom, I'm going to do another fraction, 0.04, and on bottom is 1.645. Arrow to the side of the fraction and square it. That looks pretty good to me. If you want to put parentheses around the bottom fraction, you can. I'm going to hit enter. And it tells me that n has got to be greater than or equal to 418.58. So basically 419. That's the minimum size I need to do. And I go over here, and there's my 419. All right. And 3 digits on the Z-star is plenty to get us to the accuracy of the answer that they want as we do things. Well, let's take a look at the next one. A simple random sample of size n is drawn. The sample mean x bar is found to be 18.3. All right, so they want us to construct a t distribution. So we're doing a t interval, a 95% confidence interval, and we're doing n is equal to 35. So this tells me that, again, we're doing a t interval. They tell us that x bar was 18.3. N is equal to 35, and we're doing a 95%. So that would just be hit stat, go over to test. T interval is option number 8. And we're doing statistics. We didn't get a list of numbers, so we're doing the statistics branch of it. And then I get to start typing in 18.3. Did they tell me a standard deviation? They sure did. SX. I forgot to write that down. Their S is what SX is on the calculator for the TI-84, 4.6. So 4.6. My sample size is 35. And again, a 95% confidence interval, so I can leave that alone. Hit calculate. And so my lower bound is 16.72. My upper bound is 19.88. Now they asked me to do the same thing, but change the sample size to 61. All right, so let's do it again. Second stat, this stat. And then we're going to option 8. And it keeps all my information, so I can just change that down to 61. And leave the 95% alone. And they tell me that it is 17.122 and 19.478. All right. So how does increasing the sample size affect the margin of error? Well, if I notice we went from 16.7 and we're up to 19.8. And then now, after making the sample size bigger, we went to 17.122 and 19.478. So our confidence interval got smaller, okay? So what did that do to the margin of error? Well, it decreased it. If our confidence interval got smaller, then that means the margin of error got smaller. And the reason is because when we look at the fraction for computing this, we divide it by a bigger number, and therefore, when you divide by a bigger number, the margin of error and the standard error basically get smaller in the process. They asked us to construct a 99% confidence interval going back to a sample size of 35. So again, same thing, we're doing some comparisons here. So stat option 8, and then all I got to do is change that back to a 35, and then change that to a 99. And so that I have 16.179 to 20.421. And they asked me now to consider how does increasing the confidence level affect things. Well, let's go back to the original. The original we said was 16.72 to 19.88. And then now we have 16.179 to 20.421. So it actually got it wider. So it actually it made the margin of error, it made the interval bigger, but also that makes the margin of error increase as well. Part D, if the sample size is 17, what conditions must be satisfied before you compute it? Well, it goes back to our normal condition. I've already gone through, and what we've done so far, our n has been greater than or equal to 30. And so we were able to go ahead and compute this because once we're bigger than 30, a sample size is bigger than 30, it's approximately normal. Even if the graph and the data is a little skewed, it's okay. We can still go through and calculate this. So we need to know that it is normally distributed. And that so if its sample size is 15, the sample data must come from a population that is normally distributed with no outliers. That's what we need to know. Unless we're given the information, all the data points, to where we can actually graph it and see if there's any skewness, we need to know that it's normally distributed with no outliers. Because if it had outliers and wasn't normally distributed, then we wouldn't be able to go through what we're doing. All right, let's keep going here. This T chart there is if you want to use it to, instead of doing the T interval formula in the calculator, you can use that to do that the formula by hand if you want. So it's up to you. All right, number 69 here. It says, a doctor who wants to estimate the mean HDL cholesterol level in 20 to 29-year-old females. How many subjects are needed to estimate the HDL cholesterol within 3 points with a 99% confidence interval, assuming the standard deviation based on earlier studies is 16.1? Suppose a doctor would be content with 95% confidence. How would this decrease in confidence affect the sample size? All right, so we're doing sample size twice. And they did give us down here the table, so we didn't have to go search for it, and we don't have to worry about doing things on a calculator. So when we think about this, and again, the only way, even though we're dealing with means, we can only find sample size with the margin of error formula from the Z formula from that one. We can't do it with the normal T star because that deals with degrees of freedom, and you need to know your sample size to figure out your degrees of freedom so you can figure out which T star you're using in the formula. So they have to give us the standard deviation. So in this formula, what it is margin of error. Sorry about that. Margin of error is greater than or equal to. Again, we get to still use Z star, and then we would use the standard deviation divided by the square root of sample size. And that's what we would end up using. So again, we're not using proportion, so we're not using the whole square root of the fraction. It's the old standard deviation based on an earlier study and then divided by the sample size. So again, they want a cholesterol within 3 points. So 3 points greater than or equal to, okay, we have a 99% confidence interval. And so our Z star is 2.575, 2.575 times 16.1 over square root of n. So again, as we go our inverse operation, divide both sides by 2.575. I get 3 over 2.575 greater than or equal to 16.1 over square root of n. Again, I'm going to trade places with the square root of n and the fraction. So the square root of n has to be greater than or equal to 16.1, which is divided by 3 over 2.575. And then lastly, we're going to square both things, and that gives me what n needs to be. So I'm going to type in this big fraction, or this complex fraction here is what I'm going to type into the calculator, is what I'm going to do here. So as I clear the screen, give me a parentheses, a fraction, 16.1 on the bottom. Let's have another fraction, 3 over 2.575. And I'm going to arrow out to the side of the other fraction and then put a parenthesis, and then I want to square it. And then I hit enter. So n has got to be greater than 190.96. Again, no matter what, we round up to 191. So it requires 191 subjects. Now we're going to do the same thing, but they want us to do, okay, how many subjects would we need for a 95% confidence interval? So really what happens here is the only thing that changes is our Z star. That's the only thing that's going to change for the second action as we do it. So for this was for 99%. For a 95%, all that needs to change is that Z star. So technically, we have our Z star here. 95% is 1.96. So really, I can go all the way down to this phase right here to speed up some time here, and say that n has got to be greater than or equal to 16.1 over 3 divided by 1.96 quantity squared. So that's the only thing I have to change. And so I'm going to go in and tell the calculator to bring up the last formula I created, and I'm going to arrow back. Whoops. I got to make sure I put a squared up there. And I'm going to change that bottom decimal to be 1.96. And I'm going to go out there and tell it to square that fraction. All right, that looks pretty darn good, and I'm going to hit enter. And it is, n has got to be greater than or equal to 110.64, so 111. So I need 111 subjects to have to where it works out where a 95% confidence interval has a margin of error of 3 points. Then it says, now that it asks, how does decreasing the confidence level affect the sample size required? Well, we went from 191 to 111. So we get to decrease. Decreasing the confidence level decreases the sample size that is needed. All right, so there's our option there. Okay. All right, let's take a look at the next one. Again, we can use, they give us a hint here, using the page. There's our page right here if we want to use it. Again, we don't have to. We can use the calculator to do some of this stuff too, and use out the 3 decimal points. A television sport commentator wants to estimate the proportion of citizens who follow professional football. All right. What sample size would be obtained if he wants within 2 percentage points with a 95% confidence interval if he uses an estimate of 52% from a previous poll? So that tells me, again, now we're going back to, we're talking about proportions, percentage points. So my margin of error is n times the square root of the p hat times 1 minus p hat over n. Oh, sorry, I don't know why I put an n in that place there. That's Z star. My apologies. Z star. Again, they want 95% confidence interval. So they tell us within 2 percentage points, so 0.02, greater than or equal to 1.96. Sorry, my fingers are hitting the, there we go, hitting the buttons there. All right, times the square root. Now this is where the estimated the 0.52% or 52%, 0.52 times 0.48, because that's what 1 minus 52 is, over n. And then now I need to go ahead and just start solving that for n again. And again, I'm going to take it slow, 0.02 divided by 1.96. And I'm going to stop for a second. Yeah, they want the actual sample size. All right. Greater than or equal to the square root. What's 0.52 times 0.48? 2496. All right, and then we got to square both sides. So 0.02 over 1.96 squared, greater than or equal to 0.2496 over n. Trade places. N has got to be greater than or equal to, and again, remember, you can always pause this and catch up with me, 0.2496 over 0.02, 1.96 squared. So that's what I'm going to type in the calculator. And again, I'm going to, I'm just going to start fresh. Alpha x gives me a fraction, 0.2496. On the bottom, alpha x again to give me another fraction, 0.02 over 1.96. I'm going to go off to the side of that fraction and push squared. So that's squaring that whole bottom fraction. I hit enter. Ooh, that's a big sample. So n has got to be greater than or equal to 2397.15. Again, 2398. We always round up to the next integer. And it reminds us, round up to the next integer on this assignment. 2398. Now they said what sample size would be obtained within 2 percentage points with a 95 if he does not use a prior estimate. Okay, so when they don't use a prior estimate, what we're supposed to do is we're supposed to basically use a p-hat of 50% of 0.5. Okay, so what that's going to do is the only thing it's going to change is it's going to change the top of my fraction here. That's the only thing that it's going to change in the process. All the other stuff stays the same in the formula. So that's all these highlighted things here. That's what's going to technically change. So I'm going to skip to this part right here. Whoops, sorry. And I'm going to say, okay, for the second one, n has got to be greater than or equal to, all right, what's 0.5 times 0.5? Because that's what really the top of it is. 0.5 times 0.5 is 0.2500. So 0.2500 over that fraction being squared. So I'm going to go up and grab my last answer. Actually, I can do second enter, last answer. And then I'm going to go up to the numerator carefully, hopefully, and change that to be 2500. Ah, crud. I wasn't careful enough. All right, 2500. And then I'm going to hit enter. And n has got to be greater than 2401. And then, so there's my second answer, 2401. And then they asked me, why are the results from A and B so close? Well, the reason why they're so close is when we think about it, 52% and 50% are really close together in general. And so even if we look at the numerator before we got into the division, these two things are only off by 0.0004. All right, so or 4/10,000ths. So that's why we're getting pretty close to the same answer here. So there's our choice here. Those are very close to 0.25. That's the one we want to choose. All right, let's keep going. A researcher wishes to estimate the proportion of adults who have high-speed internet access. What sample size should be obtained if she wishes to estimate to be within 5% with 95% confidence? And again, use the previous estimate of 0.38. So again, this lets me know, again, since I'm dealing with percentages, is what I'm dealing with. I am dealing with the fraction that has everything under the fraction underneath the whole square root symbol. So my margin of error, 0.05, 95% confidence, 1.96, square root, and now this is where I use the 0.38. 1 minus 0.38 is 0.62. over my sample size. And then now we just have to go through and kind of work to get this. Again, we do actually have the formula typed in there. So I'm going to spare the inverse operation stuff and kind of get to the setup here. 0.38 times 0.62. So this is the very top numerator, 0.2356. And then we have our little fraction being squared, which is the 0.05 divided by the 1.96. And so I'm going to tell the calculator to grab the last. Actually, I can't do last that. I got to go up to that fraction. There we go. I got to grab that fraction and then carefully change the numerator to be 2356. There we go. Hit enter. So this tells me my sample size has got to be greater than 2262. Make sure I didn't have happy fingers here. Point. Looks good there. Okay. So that'd be 2263. 2263. All right. If she doesn't use any prior estimates, that means we got to use the 50% in there. Oh, you know what? Goofball. I did write down 0.05, but I didn't change to 0.05 in that formula. That's why it looks a little off. My bad. I didn't change the numerator of that part here, the bottom as well. I just changed the very top. Oh, my bad. So that's 0.05. Let me get rid of that bottom. Sometimes being quick makes an issue there. 0.05. 1.96 quantity squared. There we go. All right, so 362.03, so 363. 363. Again, now all they want us to do here, no prior estimates, means I get to use the 50%. So as we talked about it before, all that's going to do is change the very top. So it's going to be 0.5 times 0.5, which is 0.2500, like in the last problem. So all our fraction is doing is changing just the top piece. So let's get the last formula. Try to carefully go up to the top of that formula. And change that to 2500. And that one becomes 384.16, which is 385. So it made it go up. So, and the reason why is because 38% is further away from 50%. So that's why it kind of changed as we look at it. All right. 72. Eric randomly surveyed 150 adults from a certain city and asked which team in the contest they were rooting for, either North High School or South High School. Of the surveyed adults, 96 said they were rooting for North High School, while the rest said they were rooting for South. Eric wants to determine if this evidence that more than half of the adults, so more than, that's going to help me craft my hypothesis statement. More than half of the adults will root for North High School. Which of the following is correct null hypothesis? So our null hypothesis, remember, we can only have equal signs. And again, we are dealing with proportions here. So that means I need to just look at just P being my symbol, my parameter symbol. So P equals, and then more than half, which would be 50%. And so P equals 50%. That would be our D there. Again, the alternative hypothesis is where we have to do something a little different. All right, here's what 73 wants. 73 wants what the alternative hypothesis for that exact same scenario would be. So that I'm looking for H1. Again, still looking for the P. Again, we can cross some things off here. Since we chose D for an answer, that means that the north high, south high equals is not a choice here. So we're going to take that off. In a alternative hypothesis, we should see an inequality symbol. So the equal signs come off. And that leaves us just that one symbol. And that matches up with up above here when I underline more than half. We're looking for an alternative greater than 50%. So what is the definition of p-value? Well, p-value is the probability of observing the actual result, a sample mean, for example, or the proportion. Something more unusual just by chance if the null hypothesis is true. So the answer here is B for the definition. Number 75, as we fill in the blank, if we do not reject the null hypothesis, if we do not reject, so that's like a fail to reject. When the statement in the alternative hypothesis is true, we made what type of an error? And we made a type 2. If the type 2 is associated with failing to reject and making a mistake there, a type 1 is associated with reject the null hypothesis. So since they talked about which type error is associated with the do not reject or fail to reject, that's always a type 2. Type 1 is always with the reject. If a hypothesis is tested at an alpha of 0.05 significance level, what is the probability of a type 1 error being made? Well, a type 1 error is exactly whatever the alpha is. And so that would mean that if it's 0.5, then the probability of making a type 1 error is 5%. Remember, we're not really concerned about figuring out the probability of a type 2 error. It's a type 1 error is really what they're assessing us for. So 77, they asked us to go through and state the nulls and alternative hypothesis in symbols and words, then go through, explain what a type 1 error, a type 2 error is, for definitions here. So we're going to just kind of run through this one pretty quickly. 3 years ago, the mean price for an existing single-family home was $243,767. A real estate broker believes that the existing home prices in our neighborhood are higher. So state the null hypothesis in words. The best choice is the mean price of a single-family home in the broker's neighborhood is that. Again, we want a statement of any equality. Different is it means not equal to. Greater than, there of course means the greater than symbol. So, and again, it was specifically in the prices in her neighborhood, not all neighborhoods. So that's why that other one is said any. That's why that one's off the table. State the alternative hypothesis. Again, here the best choice again is A. The mean price in a single-family home is greater. Because she says are higher, and that's why we're choosing greater there. List this now. They want us to go through and list this in symbolically. So again, we are dealing with not percentages. We're dealing with the mean price. So that means I got to use mu. So mu is equal. So mu. Sorry, let me get rid of that squiggly. Mu is equal, and then our mean price of 243,767. That's the same numbers. Got to be used twice. Can't change up numbers. And then mu again, and then greater than is our symbol on that one. What would it mean to make a type 1 error? Okay, the broker rejects, because again, type 1 is rejects the hypothesis that the mean price is equal, so rejects the null, equal to 243,767, when the true mean price is greater than. 243,767. And what would a type 2 error be? Would be, again, we failed to reject, so we do not reject, so fail to reject. The null hypothesis price is equal to the 243,767 when the true mean price is, Mr. Stevens, you're looking off on your stuff wrong. That should be, sorry, go back up to that one up there. My apologies. That should be equal to. This one should be the greater than. My apologies. And then this down here, basically I filled in all the blanks as we look at, hey, we're supposed to use this symbol, blah, 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 for all the blanks. So we really don't have to worry about that. Remember, our final is going to be multiple choice, so it's really picking these correct interpretation statements is what we got to be able to do. What's the correct null hypothesis and alternative hypothesis statement that is written? All right. According to the report, the standard deviation monthly cell phone bill was $49.18 3 years ago. Research suspects that the standard deviation of monthly cell phone bill is less today. The null hypothesis is not rejected. So that means we failed to reject. Choose the correct answer below. So which would be the correct choice there. So I'll give you a moment to read. Again, so if we do not reject the null hypothesis, that means we do not have sufficient evidence. So there is not sufficient evidence. Just going off of the not rejected. So we failed to reject. That means we do not have sufficient evidence. According to the Federal Housing Finance Board, the mean price of single-family homes here, the real estate broker believes there is a crunch. The mean price decreased since then. Again, the null hypothesis is not rejected, so that means there's not sufficient evidence. So I can get rid of these bottom two. Now I got to be careful on which one of those two. So there is not sufficient evidence to conclude that the mean price has decreased, because again, she talks about that she believes that it has decreased. So that's that's the difference between A and B. A had increased. She talked about it being decreasing. All right. Again, another one here. If you want to pause, do this. You can do this one if you wanted ahead of me. Again, where this one now is we're talking about percentages, so this is a proportions test. So like an example would be a 1 prop Z test is what we're doing here. They asked us to complete the information below. So our symbols are P's because we're dealing with proportions. The null hypothesis is always an equal sign. So now they say, according to the Center CDC, 9.9% of high school students use electronic cigarettes, so 0.099. We always write it as a proportion. The counselor believes it's higher, so greater than 0.099. And then if the sample data indicate the null hypothesis should not be rejected, so we do not reject the null hypothesis, that means that we do not have convincing evidence to support the claim that it is higher. So there is no, so I'm going to get rid of the sufficient. There is not sufficient evidence to conclude the proportion of students exceeds. So this would be A. All right. Suppose if in fact the proportion of students at the high school studies electronic student. So they say that it actually is 20 or 22%. What type of error? So since we failed to reject, it would be a type 2 error. So it would be a type 2 error. Uh, 81, the probability of observing the experiment result with a sample mean, for example, or something else just by chance, the null hypothesis true is the definition of what? Well, that's a definition of a p-value, is what that is. So now they want us to go through, and I'm going to do this 82, and then I'll do another video for the remaining problems. just to try to split up the length here. They asked us to test a hypothesis using the p-value approach. So should we reject or do not reject the null hypothesis? So again, we are dealing with p's here, so that means that I'm doing a one prop z-test. Anytime we see the hypothesis, the h sub o, that means I'm doing a test, not an interval. So I'm going to do stats over to test, and I'm going to do a one prop z-test, option number 5. And my null hypothesis, 0.45. They tell me x is 62. 150 is the n. And we are doing a less than. So I need to go over to less than the null is what that's saying. So I'm choosing a less than what we said in the null hypothesis. And go down to calculate, and I see my z-stat, my z-statistic. That is my negative 0.9027. But the key thing I want to look at is the p-value. The p-value is the 0.1834. And then we're supposed to compare that to 0.05. So my p-value is 0.1834. 0.1834, and I compare it to 0.05. Well, that's greater than. So that means I have to, I fail to reject, or we do not reject. We do not reject the null hypothesis. There's not sufficient evidence to support the claim. So since our p-value is greater, so it can't be the first two, we do not reject the null hypothesis. Okay? Again, I'll pick up the other problems on the next video.